Today's topic is Azure AI in Power BI. So that's what we're going to be talking about today. And I have Peter Shen with me today on the show. Hi, Peter.
Hi, Kazeem. How are you?
Very well, Peter. Thank you for joining us on today's episode of the Tech Talk. So let's begin with an introduction, Peter. So let's learn a little bit about you and what you do, Peter.
Excellent. Well, my name is Peter Shand, and I'm a principal cloud solution architect at Microsoft. I've been in the tech industry for longer than I'd care to share, but yeah, close to 20 years now. Different aspects of it. I'm originally Jamaican, but now I live in South Florida in the United States. So that's a little bit about me. I don't know if you want a little bit more.
That's fine now, Peter. So we've had on the show that on the past episode of the show, we've talked about Power BI, we've talked about Azure AI as well. So I believe people are a bit familiar with the topics already. But I'd like to ask you, Peter, how do we connect the dots, or should I say, what's the relationship now between AI and Power BI? So let's start with that one.
Well, I'd like to step back a little bit, Kazeem, and then just define a few little terms that might be useful. So,
Okay.
we use the term AI sort of loosely to sort of encompass everything that we're doing with machine learning and deep learning and so on. However, let's kind of define some terms. So, machine learning is a data science technique that allows us to use an existing data set to forecast future behaviors, outcomes, and trends. So it is essentially where we're using computers to learn, or computers are learning based on existing data sets. AI, on the other hand, is usually leveraging machine learning capabilities to mimic human behavior and decision making. So when we say AI, from Azure AI, it is both AI and machine learning, and there are different use cases, and we'll dive into that a little bit more. But connecting the dots for you, Microsoft wants to bring predictive capabilities of machine learning and AI technologies to as many users as possible, right? Yeah. And the trajectory towards increasing exposure to these services has been on a steady upward slope since, in the past 5 or so years. Services like Azure Machine Learning, which is a branded service, Azure Databricks, or cognitive services from Azure, are somewhat geared towards experienced data scientists and data engineers, allowing large swaths of an organization's users or in universities and so on to be in the Azure portal and leveraging the tools that I just listed is not necessarily feasible. So bringing some of these services closer to the citizen data scientists and data custodians using the Microsoft Power Platform, and by extension Power BI, starts to achieve Microsoft's ultimate goal, whereas many personas within organizations are able to access these capabilities because many more people use Power BI, right, than use the Azure portal. So that's the core reasoning to bring all of this sort of capabilities closer to the users, to more people. Yeah.
Okay. Thank you very much for that. I was going to check what Azure ML is, but you already touched on that one already. So I also want to ask, what language or what languages do we need to learn to work with machine learning? And are there also easy to work with tools that one can leverage? Usually when people hear Microsoft, they like to think that Microsoft have this culture of making tools very easy to use. So one is, what languages can we leverage, and are they easy to work with tools for ML?
Well, it's interesting that you say that, and it just depends. So okay. Azure ML can be used for any type of machine learning, from classical ML, deep learning, supervised, unsupervised learning. Whether you prefer to write Python or R code, which are the primary languages for data scientists, developers, using the software development kit that's a part of the service, or if you want to do no code or low code, leveraging the Azure Machine Learning Studio, you can build and train and track machine learning and deep learning models, regardless of your level of, expertise as it relates to the core programming languages. So, some of these services within Azure Machine Learning allow data scientists to just take features or inputs provided for example, sales data, and the service will assess the data for you and automatically produce and compare dozens of models to help you find the best fit. Without you writing a line of code. So, true to Microsoft form, they're trying to make it as easy as possible, for production ready or more advanced use cases. Definitely the coding with Python or R would be the way to go if you have those types of use cases, right? But there are other places that you can go as well outside of Azure Machine Learning. I mentioned services like Azure Databricks, where you can spin up data science clusters. There are also Azure Cognitive Services, where there are pre-built models for specific domains, stuff like natural language processing, text analytics, Microsoft Vision, stuff like that you can also leverage. The latter will also require some programming language. However, it's sort of tapping into an API. So you can, in many cases, you can use other languages outside of R and Python, like .NET and so on, to actually tap into some of these cognitive services, APIs and so on. So it's broad. It just depends on where your mind wants to take you. I think Microsoft allows you to sort of explore and use different options to achieve those goals, right?
We also have DevOps, right? And I believe a lot of people know about DevOps. But just like we have DevOps, we also do have, a terminology known as MLOps, right? So I want to check with you, what does MLOps, what does it mean, and how does it differ? What's the difference between MLOps now and DevOps? Do you want to walk us through that quickly?
Oh, well, yeah, that's one of those. That's a tougher question, but let's try and let's see if we can unpack it. So
Okay.
let's first start with DevOps. So DevOps is a combination of tools and practices designed to increase an organization's capabilities to deliver faster and secure application development, right? So development plus operations essentially is DevOps. That's simplifying it a lot, right? So some of these benefits include rapid application development, improved communications and collaboration between stakeholders, increased employee engagement, enhanced productivity, automation, documentation and code synchronization, and continuous integration and delivery. Machine learning operations is based on DevOps principles, right, and practices to increase the efficiencies of these workflows. For example, continuous integration, delivery, and deployment. MLOps applies these principles to machine learning processes, with the goal, similar to DevOps as well, is faster experimentation and development of models, faster deployment of models into production, and quality assurance and end-to-end sort of what we call lineage tracking. So in short, machine learning plus the continuous development practice of DevOps is MLOps. There are some key differences there that we have to take into consideration. MLOps includes an exploration phase, right? So exploration in its in its entirety could mean that that particular model, that particular process doesn't necessarily make it into production. That's not necessarily something that needs to be addressed, in pure DevOps, right? It might become clear that the outcome can't be achieved, right, after reviewing the data sets. Sometimes if you apply a typical DevOps way of working in a data science project, you might not find success because of the uncertainty associated with the data and the quality of that data, right? Sometimes you're just exploring raw data sets and not necessarily the trusted sort of data that typically is being used for applications and so on. Data quality requirements and data availability can make or break the process. It's not, in a lot of cases, the data changes, right? And the sort of labels and the target outcomes also are changing dynamically as well. We call those things drift. So you have like data drift and concept drift and so on. And those things are not necessarily things that are going to affect a traditional software development project. And there's also a constant risk of degradation of these models and so on, because again, as I pointed out, the drift and so on that occurs as or inputs and features and the outcomes change. So those are some of the things, but one of the other things that is also key is with many machine learning projects, you really need specialists and domain experts. For example, if you're building models, I was watching a program recently. You're building models to stop disease from spreading in certain trees, elm trees in Norway. You're going to need Norwegian elm tree experts as an integral part of the process, throughout the process, to validate the models and so on and so forth. And some of these things aren't things that typical software projects kind of face, because once the developers get going and the project has been designed, yes, there are things that might change, but it doesn't change necessarily as explicitly as what occurs in MLOps. Yeah.
Oh, okay. Okay. Thank you, Peter. Just before we go on break, I hope, you have a demo, something really quick and dirty to show us, that it might not necessarily be something you want to show live, maybe one of those projects that you've worked on in the past. But quickly before we go on break now, I've decided to title today's topic, AI in Power BI. So I'm sure people want to know about some of those AI features that we have in Power BI, right? So do you mind telling us about some of these fun Azure AI features that we have in Power BI now?
Yeah, so there are a couple, and it depends on how you want to work and your use case and the user that's accessing it. So we're familiar with Power BI Desktop, right? And within Power BI Desktop, they've added AI capabilities, one based on cognitive services, which is text analytics and Microsoft Vision. And then another facet that is based on Azure machine learning, where you bring in models that you've already trained and put into production, right? And that's in Power BI Desktop. If you go to the Power BI portal, there are additional options as well. Those are also listed, but there is a new concept called, relatively new, called a data flow that allows you to essentially take the data sets that you've sort of connected to or linked to within the Power BI portal, and you can dynamically test and train models and deploy models into production within the context of the Power BI portal. So there are a couple of options, and what I suggest is just explore. Once you get access to it, just try them and see which one fits. Yeah, but go ahead.
Okay, so we need to take our break now. But before we go on the break,
Sure.
Is there something you plan to show us? That's when we come from our short little break.
So we have some stuff here that it's actually a model that had run on some car data, related to curb weight, size of the car, and so on. And this was done
Okay.
within the Power BI portal. So I can talk a little bit more about that.
It's time to take a break now, and we'll be back in just a little bit. Yes, we're back. It's still the Tech Talk Wednesday with me, Kazeem, and I've still got Peter with me on the show, walking us through the topic today. And Peter, before the demo you plan on showing, these features that we talked about or that you mentioned just before the break, are there features that we'll need to have the premium version of Power BI to leverage, or are there are those features that comes with the free Power BI?
Yeah, it's sad to say, yes, you have to have the premium version to be able to take advantage of these capabilities. A lot of the processing associated with training and creating those models leverage consumption, of resources within Azure or within the Microsoft cloud as a whole. So yes, there's a consumption component of it that is only available within Premium.
Okay.
You can do some other stuff, for example, if you have time series, you can leverage the forecasting feature. It's definitely not as much fun as some of the stuff that you can do with the AI insights, but with free and pro, you can do some forecasting that leverages a regression model to do that. So that's interesting. You can test that out.
Okay. Okay. Thank you. So we can watch you now. I'll walk us through the demo. Yeah.
All right. So we have let me do two things first. Let's go to the Power BI desktop and we'll look at something that is pretty straightforward. So this data here and this data set is just some data coming from you. If you're in data, you'll know the AdventureWorks sample database that Microsoft has, right? And this is just some list data, list price data, and product ID data. So what I wanted to show quickly was I wanted to show a quick demo of what can be done within this environment, leveraging the AI insights. So this is the data here, the table data here. You'll notice there that there's a thumbnail column and it has binary data in it. So these are actually pictures, right? So what you can actually do, so if, for example, you had a use case where you had pictures and you wanted to figure out what they were, you can actually leverage the vision component of the AI insights, and you'll see it come up. It takes a second here. I'm trying to do something very quick, and you'll see this option here to tag images. So what it will do is actually the Cognitive Services Vision portfolio has a bunch of images or objects that they've already trained their models to recognize. So you can actually leverage that within your environment for it to help you to figure out what's going on. So it may not necessarily figure out everything, right? There are some objects that it may recognize, some it may be slightly wrong. But what you can do is use it as a platform to sort of test scenarios and test whether certain things will work for you. So you'll see here, it came back and it added some columns, and you'll see it added tags and confidence and some error message columns as well. But if you take a look here, you'll see it tagged some of these images. So it's saying here that this is something outside, outdoors, it's a bicycle, and so on and so forth, right? And it tells you the confidence level associated with the particular recognition algorithm or run against that particular picture. So you can imagine you have tons of pictures and you just wanted to get a loose categorization of them. This is something that you could leverage. Obviously, you could write your own model, right, in Python and R, and it would be far more accurate because you'd be able to train it with the images that you already have or that will be coming into the model. But this is just, I am just leveraging something that somebody already had done, right? So this is part of what you can do. All right, so that was a quick one. Some of the others take a little bit more time because the models are more complex and take a lot more time to train and run. So this is a workspace here that was created within the Power BI portal. And what I had done was to essentially use the model capabilities within Power BI to help to predict what essentially. So there are two parts to it. You can use it to actually score. Scoring is where you actually take input and then predict what the output might be, right? And then there's inferencing, which is where you kind of try to understand what are the inputs that affect a particular model or a particular use case. So this, for example, the model it took the data, it broke it into training and testing for me, right? And it actually, leveraged that regression model and gave me back this information, which is pretty useful, and some of it is straightforward, but useful nonetheless. And what it's saying here is it's saying that the length of a particular vehicle is in terms of influence to the curb weight, which is essentially the weight of the car, is one of the largest influences on that, right? And so on and so forth. So, there's a lot of data that one can get from just running these models. It tells you what happened, how many samples were taken, and the iterations that it took to get there. The final model that was used, a saw-boating regressor, and it goes through that process for you and essentially gives you all of this information that you can leverage, and then you can use it to actually ingest additional data and then run that predictive model against it. So I couldn't necessarily run that for you, but I'll show you what it looks like. If you this is the actual data set here, the car price data set. If you see there's already a model there, but I can add an additional model if it allows me to do so. This is the demo gods working against me right here. So let's see if this comes up. It's not actually coming up. Let me try and refresh this. 1 second. Apologies for that. I was working this morning. All right, so here are the actual features here. Column name, make of the car, fuel type, aspiration, number of doors, and so on. So that's the data I'm working with. You click on this little brain here, and you can add a machine learning model, right? It wants you to tell it what's the outcome that you're interested in. So, for example, curb weight. It analyzes that data, and based on the data type, what it will say is that a regression model is going to be the best type of model because we're going to end up with a whole number, the best type of model for this type of data. And then you run through the process, and it goes ahead and it breaks the data into so it also is asking you here which so here what we have are the actual features that we're working with. So it will auto select some of the features that based on the data set it thinks might be influential to your model. However, you also have the option of essentially selecting whatever you feel like might be interesting to you. All right, and then
okay.
Once you do that, then you
Peter,
ahead,
sorry, I think we need to wrap up now. But I'm sure this is more like whetting our appetite on a webinar, right, that we have coming up soon. So where you're going to be showing us more of this, right? I would like to just quickly ask Peter before we wrap up on the show today. Are there resources you'd like to share for people who are interested in learning a little bit more about this?
Excellent. So that's a great question. So a great place to start is Microsoft Learn. If you go to the Microsoft Learn website, there are a bunch of courses, self-study that you can take. You know, there are fundamentals courses on data science and data engineering, as well as some on artificial intelligence. Another source as well, and it might also be good for building networks. I know we're in a university, setting. LinkedIn Learning also has excellent courses, but that are less cloud provider specific. So it's more generalized. And then, just for those that want to explore, you can take a look at Science Direct and Kaggle, Kaggle, and those are also great places to explore and stoke your imagination. So I hope that was helpful.
Oh, okay. Okay. So this is, I guess, how much time is going to permit us on today's episode of the show. So you've heard it from Peter, and I did mention that we have a Tech Saturday coming up on the 31st. So you can hit the Lasso CBT social media pages to register for that one. So Peter is going to be online with us to put us through, plenty of these kind of related demos. And so if you'd like to have a rewatch of this particular session or the previous episode of the Tech Talk, so you can do so on YouTube. So it's the Tech Talk Wednesday on YouTube. So let's continue to keep safe now, and let's do this another time. And from myself and Peter, it's a bye-bye now.
Take care.
Thank you. Bye-bye.